Today we're going to work on Unit 3, Lesson 3 in second grade math expressions. Geometry is our focus. Geometry is just a big fancy word for shapes. Okay, we're going to talk about shapes that you already know. We're going to talk about the square, the rectangle, and the triangle. Just as a quick review about what we already know about those shapes. A square is a quadrilateral. That's the fancy word for any shape that has 4 sides. Quad means 4. A square we know has 4 equal sides. That's what makes it so different from a rectangle or any other quadrilaterals, is that the square is the only one where all 4 sides are exactly the same length. Remember, length means how long a side is. So I'm going to go ahead and draw a square, and when I draw it, I want you to pay attention to a couple of things. I want you to look at the where the lines meet. I want you to look to see if the shape is an open shape or a closed shape. Okay? Check to make sure that I have my sides, like we said they have to be a square. 4 equal sides. That means the length for all the sides is going to be the same. I'll do my best. I'm not perfect when I freehand draw shapes, but I'll do my best with my eyes to make sure they look about the same. 1, 2, 3, 4. Okay? If you pay attention to the sides, you can see that they're about the same length to make sure that it does in fact look like a square. Now I told you to pay attention to where the lines meet, where they touch each other. Where they touch each other is called the angle. We talked about this on the last video. The angle is the inside part, the inside corner that we can mark as either a right angle, because it makes a perfect L, or as a too big angle or a too small angle. And on a square, because the sides are all exactly the same length, they all make perfect right angles. So there's my square. I've got my angles marked. Now the other thing that's made, when you make 2 lines meet, it does make an opportunity for an angle inside of the shape. But when 2 lines meet, it makes something on the outside of the shape too. This thing that's made on the outside of the shape is called a vertice. Okay? So vertice is just a fancy geometry word for pointy corner. Okay? So we have 4 vertices. 1, 2, 3, 4. They are on the outside of the shape. And then we have 4 angles. I'm going to change the color so we can see those a little more clearly on the video. And these angles, when you look at them, you can see that they make L's. Now, they're not all perfectly L's, like ready to write L's. But if you take that perfect L and you flip it, it's still a perfect L. And if you flip it, it's still a perfect L. And if you flip it, it's still a perfect L. We didn't change the way the L is open to make an L. It's all open like this. We just flipped it upside down, right side up, and turned it different directions. It still stayed an L, right? See how my hand is doing that? We didn't change the angle. We just changed the way it was laying. Changing the angle would look like this. Or like this. See if I can do it with my fingers without hurting myself. Too far open. That would not be in perfect L because this space is too big. Okay, so I've got my 4 purple angles on the inside. They are all just right angles. And I've got my 4 vertices on the outside. The only way that can be created is if our sides, all 4 sides are the same length, which is the most defining attribute of a square. Okay, so we've got our square. I'm going to go ahead and take off my marks for my vertices because our focus today is actually going to be on labeling our lines. Okay, so we're going to label each vertice, each part where they come together, where the lines come together, creates that pointy corner, a vertice. We're going to give it a letter name. Okay, you might be like, what? Why are we putting letter names on it? Well, we've got to kind of have a way of saying which part of the shape we're talking about. So I'm going to start, I'm going to start in the top left side, because when we read, we always start top left and we go this way. When we write, we start at the top left and we write this way. When we count, we start at the top left and we count this way, okay? So that's the way I'm going to work when I'm labeling my vertices on my shape, okay? You can pick any letter at all, okay? I'm going to start with A on this shape. You could use M. You could use S. You could use L if that's your favorite letter. You could use any letter you want. The key is that all the letters for all the vertices have to be in a sequential alphabet order, okay? So I'm going to start with A. Let's grab a different color here. This is one vertice. I'm going to title it A. Then I'm going to go left to right and name this one B. I'm still going to go left to right and I'm going to name the next one. Actually, you know what? I'm going to go clockwise. So I started here, went here. My next one will be C. My next one will be D. I've labeled all my vertices. Now there's one letter of the alphabet that I really don't want to use when I'm labeling the points on my shape, and that's O. And the reason I'm going to stay away from the letter O is it can get kind of tricky and make you think you're talking about a number 0. And so I'm going to stay away from that letter completely. So there's a no O rule when you're labeling your shapes, okay? I'm going to remind us of that. There's an O. No O, okay? Now I've got my vertices labeled. Now the next thing I want to do is I could use my ruler, my centimeter ruler. Remember, a centimeter is a standard unit of measure, the size of my pinky. I'm going to draw that green line to help you see the width of a centimeter. Remember, it's a very small unit of measure. Okay? I would want to mark the lines on my shape to tell me how many centimeters are on my shape. So I might mark here and here, here and here, here and here, here and here. Okay? Now my shapes are all marked up now, but if I understand what each part of the labeling means on my shape, then it won't be confusing for me. I know the purple is showing me right angles, right? That's all it's showing me. I know that the letters are naming each of the vertices, each part where the lines come together, and they're in order. And I know that these green lines, I would really use if I was really measuring it, I would use a centimeter ruler and I would line up the ruler and I would mark where the lines are. But I didn't have one that was the right size for showing you this on the board for a video, so I just kind of wrote them in. You would never do that. You'd use a ruler. But these marks are measuring marks, okay? And they're telling me how many centimeters this line is worth. Okay, so let's talk about our lines. We have an A, B line. We have a B, C line. We have a C, D line. Okay, and we actually have an A, D line too. So we would have 4 lines. 1, 2, 3, 4, which fits because on our shape we have 4 sides. 1, 2, 3, 4. Okay. When we talked about a square, we talked about how we know that all the sides are the same. So when we measure the AB line, we count the spaces in between to see how many centimeters it is. Let's get a new color. We'd be counting, here's the edge, the 0 edge, we'd be counting 1, 2, 3. It is 3 centimeters long, okay? So it is equal to 3 centimeters. Now, since we know that each side on a square is exactly the same, we would not have to measure the next side. We can, just to be sure. 1, 2, 3. So the line BC is also equal to 3 centimeters. I could skip the work on the other 2 sides because my eyes can see that it's a square, and if I use the information I know about a square and its sides being the same, I know that the length, the distance around the whole square is going to be 3 here, 3 centimeters here, 3 centimeters here, and 3 centimeters here. The distance around my shape has a fancy word. It's called perimeter. We're just going to call it distance around the shape. Like if I was a little runner and I wanted to jog all the way around that shape, I just wanted to run. If I wanted to run all the way around that shape, I'd run 3 centimeters, then I'd turn and run another 3, another 3, another 3. If we wanted to know how far total I ran, I could add all these centimeters up, okay?